Okay, now we can go. Okay, so now that we're recording, this Thursday, and if you look at your schedule, you'll see it says something like lecture in Blackboard or something like that. I have to be in a conference, and it's like a Zoom. Oh, it's going to be so thrilling. It's like a Zoom conference all day with State Department people. So I won't be here this Thursday, but the lecture will be in Blackboard. So if you go in there, and if you don't know how to go to Blackboard, I sent an email to everybody. It really was an announcement. I think the email just kind of said, the email didn't include the video. I don't know why. But check that out. Make sure you can watch that before class on Monday. So just FYI before we get started. Okay. Any questions before we get started? Justin, you good, buddy? Okay. Okay, let's get rock and rolling. So today is over really a review of how to solve quadratics. So I'm just going to call it solving quadratics. Solving quadratics. This is just something you have to know. There's two main things you have to know. One is how to solve them by factoring. And it's not necessarily the solving part, it's the factoring part we have to know for this semester because of so much simplification we're going to do is based around factoring. And then just solving them, we'll probably go over the square root method for a minute. And then the quadratic formula, which you guys are usually most familiar with. And look, this is an assumed thing. I assume you guys know this stuff already, and it's more just, hey, I haven't seen this in a few days, and I need to review over it because I just haven't used it in a while, but it looks really familiar. Okay, so first off, I believe your book does start with the quadratic, or the how to factor. Let me make sure I'm on the right kind of same pages of the book. Yeah, so if we were going to solve a quadratic, well, let's just talk about the quadratic in general. So the quadratic, traditionally the way it's written, is in this ax squared plus bx plus c form. If it's an equation, of course, it's got to have an equal sign. We'll put equals 0. There's other ways to write this. For factoring purposes, we're going to start with this way. Sometimes I'll call this the standard form. Your book doesn't give it a name, actually. So I'll call it the standard form. So if we had something like, let's say 4x squared minus 2x equals 0. Now, I know this doesn't have a c, right? And that's fine. For a quadratic, you cannot have a b or a c, but you have to have an x squared term, right? If we didn't have an x squared term, it would just be a basic solving equation. So the way you solve these is by factoring. So we're going to solve by factoring. Solve by factoring. First step, you got to get one side equal to 0. So I'm going to put equal 0 there just for short term. We've got that already. We've got one side equal to 0. 2, you're going to factor the non-zero side. And this is the doozy of the step, okay? Because we have to look at this non-zero side, and we have to kind of think in our bag of, our tool bag in a way. Like, how can we factor this? Because there's a lot of different ways to factor. But I'll tell you, the first always is to check to see if we have a GCF. And we do here. And this is just basic GCF factoring. 4 and 2 are both divisible by 2. You've got an x squared and an x. You can pull out a 2x, right? And you're left with 2x minus 1 equals 0. And notice what we've done is we factored it. By factored, that means that we have addition or subtraction of terms, and it's turned into multiplication of terms, okay? So we factor the non-zero side, and then we just set each factor equal to 0. Set each factor equal to 0. So 2x equals 0. 2x minus 1 equals 0. Well, 2x equals 0. X has got to be 0. And 2x minus 1, add the 1, divide the 2, and you wind up with 1/2. So set each one equal to 0 and solve. Boom. And we're done. Now, you're more than welcome to check these. They're not that hard to check. Like if I put 0 into you got to go back to the original equation. If I put 0 in, 4 times 0 squared is 0, minus 2 times 0 is 0. So 0 minus 0 equals 0. One half squared is 1/4 times 4 is 1 minus 2 times 1/2 is 1. So 1 minus 1 is 0. You can pop that in the calculator to check it. Boom. Okay. Now look, it is not a coincidence that if you think of this as a polynomial, that we have a degree of 2 here, right? Remember the degree, which is the highest exponent on the x. It's not a coincidence that the degree is 2 and we have 2 answers. And actually, we have 2 factors that have an x. Those all coincide. We're going to see that later on in about 3 or 4 weeks, where it turns into, well, if we have a third degree, that means 3 factors, which means 3 solutions. So these go together, okay? So the degree, the number of factors, and the number of solutions. Yeah, I should say factors with an x. 2 doesn't matter so much. Okay, hopefully that's just easy stuff that you guys have seen. It's just drudging it back up. Okay, the next form of solving by factoring is, let's do one where like x squared is just by itself. Let's say we had, let's say x squared plus, I don't know, 8 equals, let's say 9x. Okay, I think this will work. We'll see. X squared plus 8 equals 9x. Well, first thing, of course, we got to get 0 on one side, right? We got to move this 9x over and put it in the middle. So we get x squared minus 9x plus 8. Right? Remember, this was the easy way to factor trinomials. There's no GCF, right? Then if x squared was by itself, you can just set parentheses. Put that on silent. You just set up parentheses, and then you've got to think, what 2 numbers multiply to give you positive 8, and then add to give you a negative 9, right? That's going to be minus 8, minus 1, right? Multiplies to give me the positive 8, adds to give me the negative 9. And then we factored it, right? So we factored this trinomial. So it turned into addition and subtraction down to multiplication. Now two terms being multiplied. So x minus 8 equals 0, x equals 8. X minus 1 equals 0, and x equals 1. Okay, hopefully that's just review. If it's not, slow me down. Actually, this is, I think, where I put some extra stuff in the Blackboard shell. This is the kind of stuff that's in there. Okay. And then it's, well, what if it's not an easier factoring? So let's say, I'm going to steal a strip from the book. Let's say we had 2x squared plus 7x equals 4. Okay. Now this one's not as easy because, well, it's because we have the 2 in front of here. The 2 in front of the x squared, right? I'm going to move the 4 over because I know that's the first step. Now look, you're more than welcome to factor this any way you learned how to factor these, okay? I'm going to go over one way. It's called the AC method, or factoring trinomials by grouping. But you're more than welcome to just factor this however you want to. The guess check method, the bubble method, the stair method, the diamond method. These are all ways to factor these. And you can find them all on YouTube, okay? I stick to one just because it's what I teach in the remedial math, and then I bring it into the regular college algebra class. So the way this works is you actually multiply the A and the C together, right? That's what's called the AC method.
I have a question real quick.
What's up?
Should that be a -4?
Ooh, yes. I was making sure you were paying attention, man.
Okay.
That's a -4. So that is -8, right? So yeah, we get a -8 up here. I got to make sure to remember that when I bring it down. We have to think, what 2 things multiply to give me -8 that add up to a +7, right? Well, that's -1 times 8, right? Multiplies to give me -8, adds to give me a +7. I'm going to break apart that 7. 2x squared minus 1x plus 8x minus 4 equals 0, right? And then this is, you had to have 4 terms to do factor by grouping. So the way factor by grouping is worked, you group the first 2 and the last 2 together. You factor out, we can factor an x out of this first group. We get 2x minus 1. And this second group, I can factor a 4 out. And notice when I do that, these are the exact same, right? And with those being the exact same, I can factor it out. We get 2x minus 1 and x plus 4. So if you've never seen this before and you don't know how to factor these by some other way, this is called, I'll write it over here, the AC method or bridge method. Or I think your book calls it, or the other book calls it, factoring trinomials by grouping, okay? So all three of those, you can find those on the YouTubes if you want a little extra examples. But once we get to this point, just like the last two we've done, we set each factor equal to 0. 4 equals 0. And add the 1, divide the 2. We get x equals 1/2. Subtract the 4, and we get x equals -4. Okay? Pretty neat. I know, you don't have to tell me. Okay. And listen, I know what you're thinking behind that screen at 5 p.m. when you're watching this or whatever. Then I can just use a quadratic equation, all these, or quadratic formula. And I get that you can, but you have to know how to factor trinomials. You have to know how to factor trinomials for the rest of the semester. It's going to pop up in a lot of different ways. So the solving them is great. And you're right. The quadratic formula will just pop out the answer, when you plug into the formula and simplify. But it's the factoring part I need you to know. So that really, if they just had a review of factoring, I would use it. Okay. But I need you to know how to factor. I need you to know how to factor. Okay. Let's look at some more. I'm going to steal some from the book that I know are factorable. I want you to try these, kind of test yourself out. Okay. So let's see here. Let's say this is number 102. I'll pull some even ones out. I'm sorry, 104. 104. 2x squared plus 5x equals 3. So try that one. I'm going to steal another one while you guys are looking at that one. Oh, yeah, let's look at 98. 98 is 3x squared minus 27 equals 0. So try those two. I'll give you a minute. Okay, keep working for it. I'm going to work on this first one and then get to that second one. 2x squared plus 5x minus 3, right? Minus 3, right, Amanda? Not plus 3. And I'm going to do the same thing. Negative 6. That's going to be negative 1 and positive 6, right? Very similar to the last one. So we get 2x squared minus 1x. I'm going to group that together. Plus 6x minus 3 equals 0. I can take the x out. So I get 2x minus 1. And then over here, I can take a 3 out. I get, 2x minus 1. So then these match. They have to match. If you've never seen this before, these two groups have to match. What you're doing is you're actually factoring them out. And you're left with x plus 3. So set those equal to 0. Add the 1, divide the 2. You get 1/2 again. I think we've got 1/2 like 3 times now. X plus 3 equals 0. Subtract the 3. And you get x equals negative 3. Okay? The second one over here is a little different. 3x squared minus 27. First off, this thing has a GCF. 3 and 27, you can factor the 3 out. And I would suggest doing that. Just makes your life a little easier because now this little quadratic's a little, it's just smaller numbers. That's really it. And what we have, though, is it's called difference of squares. Now, you are more than welcome to factor it like the way, like you have to think of a 0x in there. But with difference of squares, x squared minus 3 squared, this is actually x minus 3, x plus 3. Right? This is called difference of squares. It's a special kind of trinomial. It's really a binomial. Now, the 3 doesn't matter with solving. This 3 out here doesn't matter at all because it doesn't have an x. The only factors that matter are going to be ones with x's. So we have to set those equal to 0. Move the 3 over, we get x equals 3. Subtract the 3 over, we get x equals negative 3. Okay? Cool. Questions? Those are like 5 good examples. You'll see kind of different ones in the solving by factoring section, but I need you to get comfortable with factoring. I need this to be a thing that we can, kind of a reflex, right, that we can do. Any questions? Or I just keep rocking and rolling. Okay, let's go to the square root method. The square root method, so square root method. The square root method is nice. We could have actually used it on the difference of squares. But the square root method says, look, if you take the square root of both sides, and we really have to have trinomial, we have to have the quadratic set up in a nice particular way. But if we take the square root of both sides, you have to attach a plus or minus. So I'm going to kind of just show an example, a really, really basic example of when we would use square root method. Let's say we had 2x squared minus, let's do plus 100 equals 0. My brain would automatically go to the square root method on this one because I can see that I can isolate that x squared without another x on the other side. So if I can isolate whatever's being squared, then I want to use the square root method. And the way you do it, it's set up a little different. First, you actually have to isolate the squared term. Isolate, and I'm going to say, because it's sometimes not a term. So I'm going to say isolate whatever is squared. Isolate whatever squared. So for us, it's that x squared. So I'm going to move the 100 over. Right? It becomes negative 100. I divide the 2, and I wind up with x squared equals negative 50. Okay, we've done step 1. We've isolated whatever is squared. And then next, you've got to take the square root of both sides, but when you do that, you have to attach a plus or minus. So take the square root of both sides. And then look, do not forget plus or minus. Okay, do not forget the plus or minus. That's just a very common mistake. So at this point, I'm going to take the square root of both sides. And the reason we do that, of course, is the left-hand side goes away, right? But when we do that, we have to attach the plus or minus. Now, typically we attach it to the non-variable side. So that's over here. So we put the plus or minus square root negative 50. So we wind up with x equals plus or minus the square root of negative 50. We got to remember how to simplify these guys, right? So now it's going to turn into a review of simplifying radicals. I use the factor tree. I don't care how you do it, just do it, okay? First off, it's negative. So the very first thing I'm going to do is take an I out, right? It's imaginary number. So an I's got to come out. The 50, I like using the factor tree. This is how I just simplify these. 50, I break it down to 25 times 2. 2 is a prime number. 25 is not, right? 25 is 5 times 5. These are both prime numbers. And since it's a square root, we're looking for pairs. I got a pair of 5s that can leave the radical. So it becomes 5i square root. 2 does not pair up, so therefore it stays underneath, okay? So plus or minus 5i square root of 2, okay? Plus or minus 5i square root of 2. And this kind of has a lot going on. If you're watching this later and you're going, oh my God, I don't recognize any of this. Well, this is solving by the square root method. Now from here down though, from right here, this is just simplifying radicals. So if you need to go back and kind of catch up on how to simplify radicals, because guys, this is a 7-week class. This is daily. And I know a lot of us have already had a 7-week class right before this, but it will snowball real fast on you if you don't stay up and stay on top of it, okay? So make sure if you're kind of struggling with this to go back and watch something, email me. I'll find some stuff for you to watch, okay, on these methods. But this is considered a review. This is just, hey, these are different solving techniques we're going to use throughout college algebra. You should kind of know them already, but I'm going to go over them just in case you don't. I need to finish this. So take the square root of both sides, do not forget, and then solve for x. Solve for, let's say the variable. Put that down. Solve for the variable, okay? So I'm going to give you another one like that and just work all the way through it. Let's say we had, come on now. Let's say we have, let me steal one in here. Yeah, this is number, I don't like that one. Yeah, why not? This is number 88. So 88 says 2x squared equals 250. So try that one. 2x squared equals 250. All right, let's see. Divide by 2. All right, we got to get the square by itself. And we get 125. Take the square root, so I'm going to do this kind of in one step. Square root, we'd have x equals plus or minus the square root of 125. It's not negative, so I don't have to bring the I out. So let's bring down the 125. It's 5 quarters. Yeah. 5, and then 5 times 5. So we've got 3 5s. But listen, it's a square root. So we're only looking for pairs. So I can take a 5 out again. And then this 5's got to be left over. Okay, so it turns out to be plus or minus 5 square root of 5. Now, In your text, the way they write this is in set notation. So it's -5 square root of 5, comma, 5 square root of 5. Now, it's been like that for like the last one as well. I just wanted to show you how they write it a little different. They don't just kind of lazily use the plus or minus. They separate the two solutions. Okay? They separate the two solutions. Okay. And then another way to use this square root method is if we have a binomial squared. So let's say we had x minus 2 squared plus, let's think. Let's say it's plus 10 equals 0. Okay. You could use, now look, there is nothing preventing you from squaring this out, or foiling it, x minus 2, foiling it out, simplifying that, getting it into the regular form, blah, blah, blah. It's just a lot more work. So you can use the square root method on this as well, because if you go back to those steps, remember, number one, I said isolate whatever is being squared. Well, x minus 2 is what's being squared. So I've got to move the 10 over, and I wind up with x minus 2 squared equals negative 10, right? Take the square root of both sides. Okay. And then notice now when we take the square root, you're left with this little binomial. And on the right, now look, 10 is well, it's not a prime number, but it's just 5 times 2. Nothing can come out of it. There's no pairs of factors. But it's negative, so I'm going to bring the I out. Okay. And then add the 2. So we get x equals 2 plus or minus I square root of 10. Okay. And again, I'm not going to do this for all of them, but your book's not going to write it like this. It's going to say, 2 plus I square root of 10, 2 minus I square root of 10. Okay.
Which way will they be on the test?
Yeah, I'm pretty sure, Amanda, it's going to be this way. But if you want to ask me right before the test, I'll check it.
Okay.
Yeah, just remind me, and then I'll look it up. It's not a big deal. Okay. Okay. Yeah. Okay. So let's do one that's a little different. It's going to cause a lot more simplifying. This is number 94. And I want you to try this one. 2x plus 7 squared equals 25. 2x plus 7 squared equals 25. Try that one. Okay, let's do this one. So take the square root of both sides. We've already got the square term isolated. Do not forget the plus or minus. So then on the left, we get 2x plus 7. On the right, though, what's different is you can actually take the square root here. If you look at the last few examples, we haven't been able to actually take the square root completely, right? This simplifies. The square root of 25 is just 5. Now, when you do this, you can either split these into two equations now, or you can wait till the end, okay? And I'm going to show you what I'm talking about. I'm going to wait till the end to kind of show you how to simplify this one because it's a little bigger to simplify. So first I'm going to subtract the 7. Now to get 2x equals negative 7 plus or minus 5. And then I'm going to divide everything by 2, okay? And what we have is we have two equations here we can actually simplify. I'm not going to put this into that bracket stuff, right? Because I can add and subtract the numerator. So we would get negative 7 plus 5 over 2 and negative 7 minus 5 over 2, okay? That's a plus or minus. Well, negative 7 plus 5, that's just negative 2 over 2. That's just negative 1, right? Negative 7 minus 5, or plus 5, isn't it? Minus 5 down here, this would be negative 12 over 2. That's just negative 6, okay? So it winds up being kind of a lot longer to simplify because we can actually do the adding and subtracting, okay? Questions about that? That's the square root method, okay? That's the square root method. Pretty straightforward, not too crazy. The last method we're going to talk about, which hopefully is something you have memorized in the back of your head, is the quad formula, quadratic formula. But before we get there, we're going to go over how to simplify fractions because that's what hinders students the most from answering these. So I'm actually going to put some examples here of what really the formula pops out. And all we're going to do now is simplify. So I'm not going to start with the formula. I'm going to start with what it kind of shoots out, whenever you do that, b squared minus 4ac, blah, 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 blah. Okay. So let's look at what the answers kind of look like before we have to simplify them. So you'll get ones that look like this: 4 plus or minus the square root of, let's say, negative 16 all over 2. That'll be a good one. We'll simplify that here in a second. We'll do 2 of these. And then we'll get, let's say, 5 plus or minus the square root of, let's say, 20 over 10. Okay. These are 2 good examples before we just get rock and roll. Okay, look. So you're going to pop this thing into a formula. It's going to come out and it's going to look something like this, and we have to simplify it. The way I do these is first I've got to simplify this radical. Look, I cannot divide 2 into all 3 of these things. And that's the thing. You have to see if there's a number divisible into all 3. Well, this isn't even, right? This is not an even number. It's some radical negative 16 number. You have to simplify the radical first. And we can. Square root of 16 is 4. It's negative. So this winds up being 4 plus or minus 4i all over 2, right? Now look, we can't add these numerators. This is a real number, the 4. This is an imaginary number, the 4i. They don't mix, okay? You've got to keep them separate. But if you look at the coefficient 4, the constant 4, and the 2, all 3 of those are divisible by 2. And you have to see and make sure that every single number is divisible by the same number. So since they're all even, 2, 4, and 4, we're going to divide them all by 2. And we wind up with 2 plus or minus 2i over 1, right? Now, we don't write divided by 1 because anything divided by 1 is itself. So we just write this as 2 plus or minus 2i, okay? So down here, same kind of thing. We can't divide 5, 20, and 10 by 5. I know our brains want to, but they're kind of lying to us. They just see the pattern, the 5, 20, and 10. But this is not 20. This is the square root of 20. So I have to simplify the square root of 20 first. So I'm going to do that up here. So 20, 10 times 2, 5 times 2. Oh, great. I can take out a 2. I'll write that underneath. 5 plus or minus. I can take a 2 out because I got a pair of 2's as factors. Now this 5's left over. all over 10. Okay. Same thing. Now we need to look. Now look, this is not a 5. This is a square root of 5. It's like 2 point something. Okay. So if you're going to simplify this, you've got to look for a number that's divisible by the constant out here, that 5. That's an actual 5. The coefficient, 2, and 10. Well, there's nothing that divides into all three of these, 10, 5, and 2. There's nothing that divides into all of them. So this is actually completely simplified. This is completely simplified, okay? And we have to recognize that. We have to be careful because this is where students mess up. It's not the formula. You probably have it memorized in the back of your head already. If you haven't used it in a while, you'll see that it'll come out real fast. It's not the formula that students struggle with. It is simplifying, hands down. Okay, so let's look at an equation where we would use, or we could use the formula. Let me still like an example out of the book. Yeah, let's say we've got 2x squared minus 6x plus 1 equals 0. Okay, so if you guys remember the equation, which I assume you do, this is A, this is B, this is C. It has to be in that standard form we talked about at the beginning of the lecture, ax squared plus bx plus c. You got to have a 0 here. This has to be 0, okay? And then when the A, B, and C are right there in the formula. The formula looks like this. I'm only going to write it out once. X equals, negative B plus or minus the square root, B squared minus 4AC all over 2A, right? You learned some jingle probably in high school or junior high, whenever you learned it, to memorize it. Okay, so let's plug this in. X equals negative B, so negative 6, plus or minus the square root. B squared, be careful that you square the negative, right? So it's negative 6 squared. It's going to want to be positive 36. Minus 4 times A times C all over 2 times A. So I want you to simplify this one completely. I'm going to give you a minute. I got to run to my office real fast. See if I've got another marker. I'll be right back. this marker works. We've got, it's showing up kind of, we'll see, 6 plus or minus. Now look, it's not showing up at all. Dang it. 6 plus or minus. I like doing what's under the radical first, really. Negative 6 squared, that's 36. Minus 4 times 2 times 1. So I think of these as 3 numbers being multiplied together. Negative 4 times 2 times 1, that's minus 8. So you wind up with 28, right? Is that right? Yeah, that's right. But 28. So you wind up with 6 plus or minus the square root of 28 all over 4, right? And then we've got to simplify this. Well, the 28, 7 times 4, that's prime. 4 is 2 times 2, so I can take a 2 out. So 6 plus or minus 2 square root. Now I got a 7 left over, all over 4. And then all 3 of these are even. You see the 6, 2, and 4. I'm not worried about the 7. 6, 2, and 4 all divisible by 2. So this winds up being 3 plus or minus 2 goes away because you divide it out all over 2. Okay? So 3 plus or minus the square root of 7 over 2. And you realize the formula isn't hard. Once you have that memorized, it's not hard to put something in the formula. It's going from this formula down to the final answer that we kind of struggle with. Okay. Let's try another. Let's see here. Let's say we've got 2x squared. Actually, no. I lied. 3x squared minus 2x plus 4. So I want you to do this one beginning to end. So start this one out and work it through. I'll give you a few minutes, head start. Keep working. I'm going to start down this path. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a, right? So again, I like doing what's under the radical first. 2 squared, so negative 2 squared is 4. And then negative 4 times 3 times 4, that's 16 times 3, that's 48. So minus 48. So you wind up with negative 44 underneath that radical. So you get x equals positive 2, right? Plus or minus the square root, negative 44 all over 6. So now I've got to break down the 44. Now I know it's negative, so I'm going to bring an I out. So let's just break down the 44. So 11 times 4, 11's prime. 4 is 2 times 2, so I can take a 2 out. So I wind up with 2 plus or minus, take the 2 out and the I out. Square root, now the 11's got to stay under all over 6. And same thing, all of these are divisible by 2 again, 2, 2, and 6. So this winds up being 1 plus or minus, really 1i, but we don't write the 1 is a coefficient all over 3. Awesome. Okay. And you'll see some in the homework that break down further, that wind up being numbers. That's fine. I want you to do, you just need to do the homework. Even if you feel comfortable with this one, you need to hit the homework because I'm not hitting every single type of example that's out there. Okay. So I'm going to pause right here and give you the homework for 1.5, actually. 1.5, which starts on page, the homework, that is, starts on page 160. 1 through 33, these are all going to be odd because there's just a lot thrown at you right here. 1 through 33, and then 65 through 73, and 83 through, let's say, 103. But these are all going to be odd. And if you feel confident in them, do every other odd. Okay, if you're like, man, this is just a good review, I don't really need to see all of them, try every other odd to make sure you've seen every type of equation that can kind of be thrown out at you. So 1 through 33, 65 through 73, 83 through 103 odd. That's for 1.5. Now we're going to do 1.7 as well today, but yeah, that's 1.5. Okay, 1.7, the only thing I care about in 1.7, and I'll tell you, in past semesters, I didn't introduce this until we used it. And a lot of students struggled if you've never seen it before. And it's called interval notation. So, hold on. I think it was, is it not this book? Oh, no, it was another book that really kind of goes over, I think, better. But that's fine. There's 3 ways to really write solutions. Oh, no, that if it's not a single solution. So you've got the graph. So we're going to make a big chart here. Okay, it's going to wind up being like a big chart for the whole page. You've got a graph way of writing these, which will hopefully look familiar. You've got set notation. And then you have interval notation. And I just want to go over each one of them and how they relate to each other, because I'll tell you, in this class, we're going to use interval, and really probably throughout your algebraic careers, you've used graph and set notation a lot more than interval notation. I just want to go over a few examples of each one of them. Okay. So now what I'm talking about now is if we wind up with a solution that's like, x is greater than 5. Okay, x is greater than 5. Notice it's not a single solution, right? It's not like x equals 5. So that's what we're dealing with. Is what happens when we have solutions that aren't a single number? So like x is greater than 5. Well, on a graph, this would be a number line here, guys. And on a number line, it goes from negative infinity to positive infinity, right? And you've got every single number. Now for this one, 5 is what's going to matter. So I'll put 5 in the middle, and I'll put maybe like 6, 7, and then dot, dot, dot. Okay. 4, 3, dot, dot, dot. Now, for the graph, what you probably learned was that if it was greater than or less than, you used an open circle. Does that sound familiar? And then if it's greater than, it goes to the right. Okay. It goes to the right. So x is greater than 5. That means that we got this open circle and we go to the right. Now, in interval, though, we use brackets and parentheses. Okay, brackets mean something, parentheses mean something. Okay, brackets mean that we can actually, it actually means inclusion. So a bracket includes the endpoints, and a parentheses means we go up to that endpoint, but we don't include it. And so what I'm talking about is right here. This 5 is an endpoint on our interval, right? The lowest our x can be is 5, but it's not included because it's an open circle. It's not an equal to. So what that means is we would put a parentheses 5, okay? And look, the interval always goes from smallest to largest. So smallest to largest. So on this graph, you can see that our x value, the smallest it can be is 5, but it's not going to include 5, so it's going to get a parentheses. And the largest it's going to be is infinity. It's going to go forever to the right. Infinities always get parentheses, okay? Infinities always get parentheses. So these three things mean the exact same solution, really solution set, okay? They're the same solution. It's just three different ways to write it. Three different ways to write it. We've got the graph way, the set notation way, and then the interval, which is what we're going to use. Okay? So let's look at another one. Let's say we had x can be anything given it's less than or equal to 2. I really need to write the official set notation. I'll do the official set notation here. Here's the official set notation. You use a squiggly bracket and you say x, and then you use this up and down line. So this means x can be anything given, that means given, x is less than or equal to 2. Okay? X is less than or equal to 2. So I'm going to draw this on the graph. We got negative infinity to positive infinity. We've got 2 in here somewhere. So 3, 4, dot, dot, dot. 1, 0, dot, dot, dot. Now we can equal the 2 now. So remember that means we're a closed circle. But it's less than, so it's going to go to the left. Okay? It's going to go to the left. So what this means now for our interval notation, though, we're always thinking smallest to largest. So our smallest, the furthest to the left, this x can be is negative infinity. Now, infinities always get parentheses, always. But the largest this can be is positive 2. And look, we're including 2 this time, unlike before. So if we include 2, it's going to get a bracket. Okay, it's going to get a bracket. So if we include 2, it means we get a bracket. Okay. So let's say we looked at another one where we were kind of in between two different numbers. Let's say we were in between -1 is less than or equal to x, which is less than 4, something like that. Okay. So what this means is x can be anything given it's between -1 and +4. Now on another line, the infinities won't matter because we're sandwiched between two numbers. So we're at -1 and +4 out here somewhere, okay? And now look, we're going to use a closed circle for -1 because we can equal it, an open circle for 4. So we're any number in between -1 and 4. Interval notation, the smallest we can be is -1, and we include -1 because it's an equal to. The largest we can be is 4, but we don't include it because it's less than. So -1 to 4. Okay. Questions about this? You guys online? Make sense? Okay, the last two are kind of goofier, and we have to introduce the union notation, which really means or. What if we had one that was like, look, x can be anything given it's not 3. Okay. X can be anything. It just can't be 3. And so what that means, if we drew this on a number line, negative infinity, positive infinity, we got 3 in there, right? 4, dot, 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 2, dot, dot, dot. We're going to have an open circle at 3. And look, we can be anything to the right of 3 or anything to the left of 3, right? And what this actually creates is 2 intervals. We've got this first interval right here, the left part of 3. We have the interval to the right part of 3. So because it creates 2 intervals, we've got to think of this as an or. Look, x can be anything in this interval to the left or this interval to the right. So it's an or statement, okay? And an or statement in mathematics is called a union. So if you have an or statement, we're going to use a union symbol. So the way we write this, we still go left to right. So the smallest our solution can be is negative infinity. Then it goes up to 3, but it has to stop. And we don't include 3, right? So we're going to use a parenthesis. So we can be in this interval Or, now for or, we use a union. It looks like a U, but without a stem, okay? And then we're going to write the second interval. So 3 to infinity, okay? Boom. That's our two intervals, okay? Negative infinity to 3, and then 3 to infinity. And then lastly, well, what if we, because we're going to wind up having this issue. So what if we have where we can be anything except like two different numbers? We can't be -1 and we can't be +4, okay? So we think of this number line again. -1's out here somewhere. +4's out here somewhere. We can't be these two numbers. But look, we can be anything to the left, in between, or to the right, okay? The left, in between, or to the right. So really what we've created, see this, we've created three different intervals, right? It's gonna be anything as long as it's left of -1, in between -1 and 4, and to the right of 4. So I'm gonna bring this piece of paper over here to make it a little more room for me. So if I'm going to write this in interval notation, I'm going to say -infinity to -1. That's that first interval, right? If you want to think of it, that's like interval A. Or we could be in this interval B, right? -1 to 4. Again, all parentheses because we're not including these, right? They do not include them. They can't equal it. Or this last interval, 4 to infinity. So our answer is a little longer here, which is why I needed to bring that on the page in, because I didn't have as much room. Okay. So look, this is interval notation. We're going to use it all throughout this semester. I'm not going to give you any homework on it today because your book doesn't really ask questions on it like I wish it would. So I just want to introduce it to you now because we'll see it, and I'll kind of go over it. With the first few times we use it, I'll go over it again because when we actually use it in practice, it'll make more sense. So there's no homework on 1.7, but this is the 1.7 stuff that I plan to talk about today. Okay. Any questions? You guys have any questions out there in Zoom land? We good? Awesome. Okay, so tomorrow, I believe we start on 2.1. We're going to start talking about functions and all that fun stuff. And I will see you all then. I'll stay on here for a few more minutes.